Hello and welcome back. Before we continue on implementing some new features here in our game, I just want to test one last thing that we have already written, and that's our total number of players here on the server side. So I'm going to change this to say 2, and I just want to verify that if we look here, we're using that total players to sort of control how many people can connect to our server. So I just want to test this, make sure it's working. So let's run our server. All right, we'll run a client. Run without debugging. Game window should open up. We get that information from the server. The server prints that we've got a new player joining. Perfect. So let's run a second client. Okay, game window opens up. We're getting game configuration info from the server. 2 players, perfect. And it says 2 players in game, no longer accepting new players. Excellent. So if I run a new client, what is going to happen? We shouldn't get a connection. Let's just see. It should like close the connection for us here. Yeah, perfect. So it says no connection could be made. The target machine actively refused it. Okay, so that's working pretty nicely. Excellent, excellent. So I'm going to keep this for testing purposes. I'll keep our total players at 2 for right now. Maybe we'll change it back in a little while. So now that our client can connect to the server, what we got to do is we should head to the server and actually create a player object to send over to the client. So if we look on our server and we look at our game class's connect player method, so here's our connect player method inside of the game class. We can see that whenever we get a connection, we accept a connection, we send over all of that game configuration information, but then we're creating a new player for the client. So we should go initialize the player class here on the server side so that we can then send that player object over to the client who just connected. So let's scroll up to the player class. All right, and in its initialization method, we'll start. So the first thing that we'll say is we have a number that has been passed in. We'll attach it as an attribute to the player. So we'll say self.number is equal to number. Next, we are specifying the size of the player over here on the server as one of the ways that we can change gameplay. Do we want the players to be really small so they're hard to collide, or do we want them to be really big so there's tons of collisions? So we'll set that as an attribute. So self.size is equal to our constant variable player size. And lastly, I will also add a score for the player here. So I'll say self.score is equal to 0. We're going to do the majority of the scorekeeping on the server side, and then we'll pump those scores back to all of the connected clients. Now, based on the assigned player number, whether they're player 1, 2, 3, or 4, we're going to give some specific starting conditions for that player object. Mainly, we'll set their starting position, so whether or not they want to start in like the upper left-hand corner, right-hand corner, bottom left-hand, bottom right-hand corner, like their home position, and we'll assign some colors, like a primary and secondary color. So let's go ahead and do this here. So we'll say assign starting conditions that vary with player number. So we'll say if self.number is equal to 1, what do we want to set? Well, we're going to set a starting X and starting Y position. So self.starting underscore X, we'll put that as 0. Self.starting underscore Y is equal to 0. So that means if you're player 1, you're going to start up here in the upper left corner of the game window. And then let's set some colors. So player 1 will be red. So we'll do self.p color, p underscore color for primary color is 255, 0, and 0. So that's going to be all red, bright red. And then self.s color, or secondary color, will make it like a darker red, 150, 0, and 0. All right, perfect. So now I'm going to just copy this, and I'll paste it down below, and we'll put an elif. So elif, player number is 2. Okay, so player 1 started here. Player 2 will have start all the way over in this corner. So we want to use, that corner is going to change depending on how big the room is. So we're going to use our room size variable. Now, our starting X, we don't want it to just be room size, because the starting X is going to be the left side of the player. So if the left side of the player is at the room size, that means the player is going to be like off the screen. So we're going to take the starting X position and do our room size minus whatever the player size is. And that will ensure that rather than starting the player like right here at the edge, they'll start the player over here, and it will fill in this region of space. Awesome. Starting Y will still be 0, okay, because we're starting at the top. In Pygame, Y, in the Y direction, 0 is at the top, and then you increase as you go down, so that's important to note. Our primary color for this player will do green, so this will be 255 here, and then we'll do a dark green as their secondary color, so 150. I will copy this, and I guess I could have just pasted. So we'll paste. Now we'll do a condition for number 3. So elif number 3. Where are they going to start? So let's see. They're going to start in the bottom left-hand corner. So the X position is going to be 0 here. But what will the Y position be? Well, the Y position is going to be room size. We have a square room. But again, it will put the top of the player there. So the player will be off the screen. So we're going to subtract the player size to just put them up. So the top is right here, and they fill in that space. So we'll do room underscore size minus player underscore size. All right, that looks great. Their color will be, let's do blue, right? So we'll do 255 in the blue channel for our primary color and 150 in the blue channel for our secondary color. And then we've got player number 4. So we'll paste. And we'll back this up, and we'll say if number is player 4, where is their starting position going to be? It's going to be the bottom right-hand corner. So essentially, our X is going to be room size minus player size, and our Y is going to be room size minus player size. And this color will make yellow. So we'll do 255 and 255 equal red and green portions will make yellow. And then our secondary color will be a duller yellow. So we'll do 150 and 150 in the red and green. All right, perfect. I always like to have an else block just to catch, I don't know, just in case. So I'll just say else. We'll print too many players trying to join. I don't think it will happen, but let's just put an else block here just in case. Okay, perfect. So those are going to be the things that vary. I'm going to get rid of these spaces in here. We don't need those. So we'll just compact that all together. All right, perfect. So those are going to be the starting conditions that vary depending on whatever the player number is. But now we're going to have some attributes that are just straight across the board. So let's set those. So now we'll say set the rest of the player attributes. In particular, we're going to have, we're going to have an X coordinate. So we'll say self.x, and we're going to assign it at the beginning as our starting X coordinate, so starting X, and we'll do self.y is self.starting y. All right, we're going to need a dx and a dy variable to help us move across the screen to indicate, what direction we want to currently move in. So we'll say self.dx is 0 and self.dy is 0 because upon the game starting, we're not going to be moving. But if I hit like the right key, then this will change to 1. And then let's create a coordinate. Self.coord is equal to our self.x, our self.y, and so that's going to be our starting position, x and y, so like 0, 0, and then we're going to use this as like a rect, so we got to express how big we want to be. Well, we want to be player size in both the x and y direction, so that's going to be self.size and self.size. All right, awesome. The last thing we'll do is we'll set some Boolean flag variables to help us keep track of the state of the player. And so we're going to use these Booleans to change the state of the game. So like, whether the player is waiting to play, if they're ready to play, or if they are in fact playing. So we'll say self.isWaiting is equal to true. We'll do self.isReady is equal to false. And we'll do self.isPlaying is equal to false. And then let's create a status message that we attach to each player object. And what we'll do is we'll render this status message to the game window at all times. And we'll update the status message depending upon what the status of the player is. So like we'll do self.status message. And for right now, since they are currently waiting, they're waiting to play, we'll just say, we'll put an F string in here. We'll say waiting for total players, and I think that will look good. So like when we first join, we can't do anything until everybody gets in the game. So it'll say, the status message will say like waiting for 4 total players. So we're just kind of waiting right here. All right, perfect. So now that we've written the player class in our game's connected player method, after we connect the player, we should send the player over to the connected client to help sort of initialize it on their end. So if we look, let's scroll down to our game class, and we're going to scroll down to our connect players method. So here we're creating the new player object. What we now want to do is we want to send this player object over to the connected client. So we'll say send the new player object to the connected client. Okay, so how are we going to do this? Well, what we have here is a player object, right? It is a Python class. What we need to do is we need to turn that class into a dictionary, which will essentially be associated key value pairs of all of the class's attributes. Then we'll take that dictionary and turn it into a string using JSON so that we can encode it and send it. And of course, we're going to use fixed length headers to help us to ensure that our class sends with no issues. So let's walk through how we are going to do that here. So first, I'm going to create a variable, I'll call it player info JSON, and we're going to use json.dumps. And what do we want to turn into a JSON? Well, we want to turn in our player object. So our player object is called player right here. But you can't turn a class into a JSON object. However, we can call dot underscore underscore dict underscore underscore on our player class, and this will take our player and turn it into a dictionary. So all of those attributes that we just set will become key value pairs in that dictionary. That dictionary we can use JSON on to turn it into a string. So now that's a string, so we want to send it. Well, first let's get a header. So we'll say header is equal to the length of player info JSON, but we want this is going to be an integer. We want that to be a string so we can add some white space to it. So now we'll say while the length of header is a string now, so we can use the length method on it, or the length function. While the length is less than our header length, so that's stored in our connection object, self.connection.header underscore length, and I'll spell it correctly this time. We're going to add some white space. So we'll do header plus equals a white space character. Now let's send the header. So player socket.send. Recall, we're in the connect player method, so we have access to the player socket right here directly. So we'll do player socket.send. What do we want to send? Well, we'll first send our header, and we'll encode it. So header.encode, and we'll pass in our encoder, self.connection.encoder. All right, that encoder is stored in our connection object. And now we'll send over the player info JSON. So player socket.send. And we'll say player info JSON.encode, and we'll use our encoder again, self.connection.encoder. Awesome. I think that that's pretty good. So now a player has joined. So let's broadcast to every single person that is connected to our server that someone else has joined. So we'll just say alert all players of new player joining the game. And so we have a method to do this. We have a broadcast method. So we'll call self.broadcast. And let's go write the broadcast method right now. All right, so we're going to come down here to broadcast. Okay, so what we want to do in the broadcast method is send information to each and every player connected about all of the players connected. So to do this, we're going to create a blank list called game state. So I'll say game state is equal to a blank list. And now we'll turn all of our player objects into dictionaries, like we just saw how to do, and then into strings through JSON, and we'll append them to the game state list. So we'll say turn each player object into a dict, then into a string with JSON. So we have a list of all player objects that are currently connected to the server. It is in our game class. It's right here, player objects. And so that's going to help us out. So we'll say for player underscore object in self.player underscore objects. So we're going to loop through that. So if there's like 4 players, we're going to loop through this 4 times. We're going to get a JSON string. So player JSON, we'll call it, is equal to JSON.dumps. What do we want to turn into a string? We want to turn into a string the player object, but player object is a class. So we'll have to do dot underscore underscore dict underscore underscore to turn this class into a dictionary of, so all of its attributes are associated key value pairs. JSON will then turn that into a string. Perfect. Now that that's a string, let's append it to our game state list. So we'll do game underscore state dot append player JSON. Perfect. So when this is all done running, game state, if there's 4 players, we'll have 4 elements in there, and each element will be a string describing our player. So that's perfect. So this will run when someone new joins the game. So we'll say, now that someone else has joined the game, send the game state to all players. So we have a list here that we want to send through the data stream, so we have to encode the list. Well, in order to do that, we'll use JSON, right? You have to turn it into a string. So we'll call this game state JSON, and this will be JSON.dumps. And what are we going to dump? We're going to dump our list game state. So now we have a string representation of that list, which we can encode and send. Well, let's use fixed length headers. So I'll say header is equal to the length of game state JSON, but this is going to be an integer, and we want it to be a string so we can add some white space to it. So we'll cast it to a string. All right, now let's actually add that white space. So while the length of our header is less than the header length, which is stored in our connection object, self.connection.header underscore length, we'll add some white space. Header plus equals a white space character. That will ensure that it is the correct size. And so now what we'll do is we'll send the header and then the game state to each and every connected player. And we have a list of all of the sockets where we need to send them to. It's our player sockets list. So we'll say for player underscore socket in self.player underscore sockets, let's send this information. So player socket.send, the first thing we'll send is our header, and we'll encode it, .encode, and our encoder is in the connection object, so self.connection.encoder, and then we'll send over the game state. So player socket.send game state JSON dot encode. It's a game state JSON's a string, so we can encode it, and we'll use self.connection.encoder. All right, so that's going to work out pretty good, I think. That was a lot. I think that was a lot here, but this is going to be a great function to sort of help us. So anytime there's game state changes and we want to push them out to all players, we have our broadcast method here. I think this is a great place to stop. And our next video, we'll look at the client script and see how we can receive the player object that we've just created and then listen for broadcasts as the game state changes. So I will see you in that next video.